In the final lesson of this chapter, we just need to add our parks. We will do this in a very similar way to how we created our rooftop elements. But this time using the park curves we separated earlier inside the building curves node group. I will duplicate the unify curve tangent node to make sure all our park curves share the same orientation. Drag from the unify curve tangent, add a reroute, and then press Ctrl J to wrap it into a node group. We will name our inputs park curves and the outputs park instances. Let's tab into this group and rename it to park elements. Now we can join this with the rest of our geometry. Inside the park elements group, we are going to do something similar to what we did with rooftops. Let's add a boundary around the edge, and then instance some trees inside our park curves. First, I want to add a bit of a lip around each park, so I will use a fillet curve node, set to poly, with a count of 6 and a radius of 1. We need to be careful, since some of our curves might be small due to the Boolean cuts earlier. To prevent issues, we will enable limit radius so the fillet does not overlap itself. Next, we will fill curve to close off the park shapes. You can use triangles or n-gons. It doesn't make much difference here. Now we will assign a material. I will use the spray green material we've been using for the trees. This gives us a nice green color, even if it is stylized. We could, of course, unwrap this and assign a material with a texture if we were aiming for a more realistic PBA style. But for our stylized version, the spray green material is perfectly fine. Let's join this geometry and add the outer edge around the park. So, we take the filled curve and pass it through a curve to mesh node. We will use a quadrilateral as the profile curve. Set a material. I will go with concrete here, which works well for this context. We do not need to unwrap or use bricks, but that is also an option. The current thickness is too large, so let's reduce the scale. Setting the size to 0.5 looks better. Lastly, let's disable Shade Smooth to remove any soft shading and keep a harder edge. We can now convert these curves to instances with geometry to instance. Now we just need to add trees to the inside of the parks. From the fill curve, we will use the output mesh directly. Let's offset it slightly, setting it to 1 should be fine. Then we will delete the boundary faces using a delete geometry node. Next, We join this with our existing geometry, using join geometry. We will then distribute points across these faces, using the distribute points on faces node. Switch to wireframe view, and we can immediately see the point distribution is way too dense. We do not need that many points. Let's change the mode to Poisson disk. Set the minimum distance to 3 and reduce the density max to 0.75. Let's add an instance on points node. We just need to make a bit more space in the node tree for this. Now we will bring in our trees collection, which is located in our street elements assets. Connect the collection to the instance is input. Now we have trees distributed inside the park areas. Of course, all of this will change dynamically depending on how many parks are generated in the city layout. We can change the layout seed value, and that will produce different tree arrangements. These updates happen automatically as our layout changes. At this point, the entire city is functionally complete. To finish it visually, let's enhance the lighting a bit so that everything looks nicer. Expand the 3D viewport and set it to orthographic view. On the World Settings tab, I have imported or appended the Cubus City Golden Ire World file from the original course resources. Switch over to viewport shading and ensure both scene lights and scene world are enabled. Add a sunlight object to the scene. Set its strength higher than default, and maybe give it a slightly yellow tone for a warmer, golden look. Rotate the sun in the viewport until we get an appealing shadow direction and general lighting balance. Now we can go even further by enabling ray tracing if we are using Eevee. This helps improve shadow quality and overall realism in a lightweight render environment. It is also a good time to explore more layout variations. In edit mode, we can extrude out parts of our base mesh, add new loop cuts, or extend shapes. We could even use the fill function on faces to connect city sections. For example, joining street corners for a clean viewing line down the road. This gives a more cohesive structure to our generated layout and makes it feel intentional and complete. There are many other things you could add to this city generator: extra instanced elements, more variations, or additional exposed parameters. As mentioned several times during the course, the system is completely modular and expandable. In this final segment, I want to leave you with a small exercise that I deliberately left out earlier.